In this lecture, we're going to see how STDC out output can slow down your program. And we are going to be using loops to prove that. Here we have a loop which is not going to have STDC out inside. We are using a while loop, but the same concepts apply to any loop you would really use. So if we run this program, it is going to run faster than the one that is using STDC out in here. And what we're going to do is go in Visual Studio Code, set up these two examples and see how fast they run. Let's head over there. Okay, here we are in our working folder. The current project is huge loops with output because that's what we want to really see and learn the behavior of. So what we're going to do is copy the files from our template project. We're going to grab that and put that in our current project. And we're going to head over to Visual Studio Code and open this. So let's do that. Open folder. Huge loops with outputs. That's the current project. And we're going to open our main CPP file and get rid of this clutter here. And we're going to set up a loop, which is going to be a for loop. I think it's going to be easier to use this. So we're going to say we're going to initialize this with a 0. Let's use curly braces and not angle brackets. So we're going to put in a 0 and I less than a 10. We're going to do exactly the same thing we've been doing all along, and we're going to put in our incrementation part. We're going to go inside and say STDC out, and we're going to put the value of I here. So let's say I, and we're going to say I and print it out. Okay, this is the program. And we're going to bring up our terminal so that we can see it running. And we're going to build this with GCC. Let's do that. The build is going to go through. And if we run this, it's going to print I from 0 to 10. Let's not use a 10 though. Let's use 1000 and see how long it runs, or even 10,000. So let's build this again. We're going to build with GCC because we just changed it. We're going to clear and run Rooster. You're going to see that it's going to run for a really long time trying to print this. And we're going to wait until it hits here. But for us to really see this, we're going to print STDC out done when it's done, when we hit the end of the program. So let's do that. And we're going to build this again. And we're going to try and get a feeling of how long we are waiting for this program to finish. So 1, 2, 3, 4, 5 seconds. Almost 5 seconds. I am counting this as I run this. So we had almost 5 seconds if we print this out. But if we comment out this std out statement, we're going to try and count how much time we wait between running this program and hitting here. And we're going to see that the time is significantly shorter than if we had STDC out in here. So we're going to build again with GCC. And we're going to clear. Let's go down and clear. And we're going to run Rooster. If I hit enter, I am going to start and count. So I didn't even count, it's done. How fast is this? So you can see that STDC out is really going to choke down your loops if you do a lot of this in your loops. And you should really be careful, especially if you have a lot of output in your program. Make sure that the moment you decide to send your program to your users, you're going to go in first and remove these unnecessary STDC out statements. So let's make this run, for example, for 100,000 times. So we're going to try and build this. Okay, so we clear and run Rooster. Let's try and count. Done. We don't even start counting. But if we remove this comment here and make the code here run, you're going to see how long we're going to have to wait. So let's build. And we're going to clear again, run Rooster. 1, 2, 3, 4, 5. We're basically going to wait for this forever. And really the choke point of this program is this STDC out statement here. So STDC out can't really handle a lot of data in significantly short time. It's going to wait a long time and it's going to slow down your program. And that's the point I wanted to make here. You see, it's not even done yet. So we're going to have to click on the terminal and hit Control C or Command C to stop this. because we don't want to wait all this time. But if we remove this stdc out statement again, so I am going to show you again. We're going to build with GCC and we're going to clear. And if we run Rooster, done, not even 2 seconds. You can see that this thing can significantly choke down your program, and you need to be very careful about this. And this is true regardless of the loop construct that you use. So if we change this program here to use while, let's comment this out, and we're going to say size t. We're going to put in place our iterator. Let's say that. And we're going to say while I less than 100,000. And we're going to go n, and we're going to print out I. Let's do that. We're going to go inside and put in the code to print I. And we're going to put in our incrementation. Let's do that, plus I. This is going to do. And at the end, print done, so that we can see that the program is really done. So we're going to say that. I am having trouble typing this here. So we're going to say stdc out stdendl here. And Visual Studio Code should have no problem with our code by now. So we're going to build with GCC and run this, clear, bring this up a little bit so that we have some breathing room. Make sure we see the code. We're going to run Rooster. And if we hit enter, we're going to basically wait forever for this. We don't want to wait all this time, so we're going to click in the terminal here and hit Ctrl+C to stop this. It is going to stop. And we're going to remove this stdc out statement like we did for the for loop above. And we're going to build again so that our code is updated, what we run in Rooster. So we're going to go down and click in the terminal, hit enter, clear, run Rooster. And the moment we hit to run, it's going to be basically done. We don't even have to wait 1 second. And this is really all I wanted to show you in this lecture. stdc out is really slow. If you are using it in a loop, it's going to significantly slow down your program. And you need to be aware of this and use this mindfully. We're going to stop here in this lecture. In the next one, I'm going to learn about do-while loops. Go ahead and finish up here and meet me there.